We use trigonometry many times to solve right triangle situations that include an angle and a side. So for our first example, we're going to find the height of a balloon that is off the ground. We have a 30-meter line that's used to tether a helium-filled balloon. Because of a breeze, the line is going to make an angle of approximately 75 degrees with the ground. So I'm going to draw a picture that gives a visual representation of this right triangle. So we've got this helium-filled balloon. That's a sad-looking balloon. There, that's a better balloon. So we've got this balloon, and usually you've got the string that's just doing this, but because there's a bit of a wind, that 30-meter line that's holding the balloon from flying away is going to be taut and straight. And that's 30 meters right there. And it's going to make, that line is going to make a 75-degree angle with the ground. So I can tell that my picture's off just a little bit, so I'm going to kind of fix it. It's not as strong of a wind as I thought it was. So 75 degrees, that's a little bit more realistic. And then we want to find the height that the balloon is off the ground. Okay, so a 30-meter line, that's this line right here, is used to tether a helium-filled balloon. Because of the breeze, the line is going to make a 75-degree angle with the ground. So that 75-degree angle with the ground is right here. We want to draw a picture that represents that visual representation or the situation. That's it. Show now the known quantities. I've got the 75 degrees listed, but I need to label the 30 meters. And we want to find the height, so we're going to call the height H. And now I've got that right triangle that I can figure out which trig function I should use, sine, cosine, or tangent. So my reference angle is 75 degrees. 75 degrees. Opposite side is H, and the hypotenuse is 30. Opposite hypotenuse is sine. So the sine of the angle 75 degrees is equal to the ratio of the height over 30 meters. Now I'm going to solve to find out what that height is. So I'm going to multiply both sides by 30, and I get an exact answer of 30 times the sine of 75 degrees. I'm going to go over to my calculator to get an approximate value. So I'm going to show you my calculator. Make sure you're in degree mode. We've got 30 times the sine of 75 degrees. I'm in degree mode right here, so I can just put the 75 in and press enter. It's going to give me an exact value, which is very strange. So I'm going to hit this button right here to get the approximate value of 28.978 meters. 28.978 meters. And that's one of the simpler right triangle problems that you'll encounter.